Welcome to another episode of 7 Minutes with Nathaniel. The reason why I've almost doubled and even more the duration time is because I realized that I'm getting even more and more detailed. Today we are now doing question 1E of NAT 2020. This question says that tangents at a squared pass through a parabola y equals to x squared. So let me draw that. So this is a graph, this is the x and y axis, this is y equals to x squared, and this is the tangent, and this is the point a squared. So now we draw a line down here. The question asks to find the area bounded this area, essentially this area. So we mark a point here called B, and we mark a point here called A because this is the A is the x coordinate. Now, to find a gradient on a line, to find a gradient on the tangent, we need to take dy over dx. So what's the dy over dx of x squared? It equals 2x. Now, we found 2x. So the gradient is 2a. So let's write it down. The equation on the line is y equals to mx plus c. 2a is the gradient, so we'll sub it into m. Y equals to 2ax plus c. Now we have y and x. So a can be substituted to form a squared. C becomes minus a squared as per normal. So now the equation on the line is y equals to 2ax minus a squared. To find the x-intercept, we had to set y is 0, and the x-intercept is b, so we need to find b. We bring the a squared over to the other side, and we'll switch the sides over. Then we take away a from both sides. Remember how to do this? Then we move the 2 over, remembering that multiplication turns into division into the other side. Now we found it. Hurrah! But doing a method which is called integration only works out the area on the curve which is here, which includes this triangle. So we'll find the area of this triangle. Most of you know that the area of the triangle is half BH. So its base is half a minus a over 2, and its height is a squared equals to half a over 2 a squared equals to a over 4 times a squared. Remembering that a times a squared is a cubed, so we put it as a cubed over 4. Now to find the integration, so we have to integrate from 0 to a x squared dx. Now you might ask, what is the integral? The adjective or integrate of x squared. It is 1/3 x cubed. Again, we'll put these limits here. To do the further integration, you have to first integrate this, then sub in the upper limit, subtract the same thing but you sub the lower limit. Because this essentially reduces to 0, it becomes 1/3 a cubed, which we can write as a cubed over 3. Now subtracting the area of the parabola from the area of the triangle, we get, putting them under a common denominator, got it, a cubed over 12. This is the answer. And have you seen a parabola before? Well, I have, and there's one at the Art Science Museum. Actually, this parabola x squared is no different. It's only a little bit taller, it's stretched, but nevertheless, the principle stays the same. Anyways, using a little bit of calculus and triangle areas and some cleverness, we managed to work out the area and realize that B has a remarkably simple relation to A. See you! Bye!